Okay, good. Now we have the next speaker waiting behind the stages. Fabio, can you do magic again and get Miimu on the stage? Thank you. Hi, Miimu.
Hi.
Nice to meet you here again, and nice to have you here. And you are going to actually continue where Pia Erkinheimo sort of left us with, so construction industry and sustainability. And Pia really kind of set the stage for you, talking about concrete and carbon emissions. So you can just go ahead and continue the story.
Thank you. And this was really nice introduction, and thank you. It's really pleasant to be here. So this is about the database sustainability in construction sector and what we can do, and how we see it, that our industry actually has a huge responsibility. We are first shaping the buildings and the built environment, all the infrastructure there, and thereafter this infrastructure is shaping us. So it affects a lot of, not only for the environment, but also for our well-being. So that's why it's so crucial that what we are doing when we are constructing buildings and infrastructures. Our construction sector, so it's actually a huge player in Finland. Over 80% is of our national wealth is in the constructed buildings and infrastructures, and also 15% of the GDP comes from this area. Investments, 60% of the investments is going for the construction sector, and 35% of the energy consumption, and 50% from the material use, which is a really big share of material use. No other industry is using that much materials, and that's of course a cause for the emissions what we are creating quite a lot. So we have a lot of things what we need to do. In SRE, we have picked up UNSGs, which we can see here. Many of those are related on the CO2 emissions, on the climate, but also on the kind of like productivity and sustainable innovations, and of course then the governance issues. We have put in the core of our strategy this kind of like life cycle perspective, how we are building the future buildings. We are focusing on the environment, so the low emission work sites, construction site, also the energy efficiency, renewable energies, and low carbon materials. Then what we want to, of course, to increase is the well-being. So we want to that our buildings and infrastructures are vital part, also the green infrastructure. So not only kind of like building concrete and wooden building, but also kind of like creating better biodiversity in our buildings and infrastructures. Then, of course, I mean, the environment in the buildings should be good, and we should also have services which are making the everyday life easier. And then, of course, I mean, the buildings and infrastructures, what we are building, so they are there kind of like many years, not only 5 years, but 100 years or 200 years there. So we need to know that they are kind of like the value is there, that they are flexible, that they can be used for many purposes in the future. So flexibility in the design, it's really important. And also that we need to have predictable and preventive maintenance, that we know in good in advance all the costs which are coming. And of course, I mean, climate change is here, so we need to be future proof, not only mitigating the climate change, but also the adaptation for the climate change in buildings. So what we have then done, so we have decided that all our construction sites are net zero emission construction site. So this means that all the energy we are using there is renewable or from zero emission sources, or then we are compensating if you need to. For example, some gases we need to use which are not yet originated from renewable sources. So then we are compensating by actually making some more woods, planting the woods. And then, of course, recycling the materials is important. And here, actually, so the data comes in a place. So how we know that how our construction sites are working, how we know that what are the materials, how we recycle them. So we need the kind of like the data, we need the real-time data, and therefore we need, of course, the APIs that we can get the data easily from different construction sites. So, and then, I mean, it's not only the kind of like the hardcore data, so those material data or energy data, but we need different type of data. We need the data from the costs, resources, what we are using, and most importantly, we need also the data of what people want, what is actually the desired built environment. So we need those type of data as well. So it's really different type of data what we need in order to make kind of like our buildings, what we are creating life cycle wise. So that's really important to understand. So what we are doing then? So we are kind of like, we have this kind of like different panels where we are asking that, well, what kind of like environments, what kind of like future buildings people want to have. And we are asking also like younger people for this type of information, because I mean, today, those buildings which we are building today, so they are of course use those younger people in the future. Then we have different citizens panels, customers feedbacks, and also we of course get the feedback from our production and design phases. So all those type of different type of data. So how we get those data, quantify the data in order to understand how we design our future buildings to use this data. So again, what are the APIs that we get the data, and that the data is in the useful form that we can use it in the design phase. In the design phase, we do quite a lot of simulations. We do the simulations of the structures, about the load-bearing things and all that, but also on the energy issues, quite a lot we do ground source heat pumps, so energy simulations on those, and more also simulations about different materials, about the CO2 emissions, carbon footprints, but also the whole solution, that how it's creating also the handprint. And here again, we need the APIs, how we get the information and exchange the information between different programs, because the mechanical engineers, they are using different programs than the energy engineers and the structural engineers and all that. So again, APIs are the core, and also that how we are getting the information from our customers, from the feedback for this design phase. So APIs, once again, that we get the data and good quality data. So APIs are important. Here is an example about what we are tackling and what we need to think about in our project. This is a project where we were together with VTT, and we were actually designing a heating system for a certain area. And here you can see actually that the heating demand is totally different. We have these few peaks here, and then actually the base load is quite low. So most of the energy we are actually getting if we have only 35 of the peak demand kind of like designed. But then again, of course, I mean, in the coldest days, so the houses need to be warm. So how we are tackling the rest of these peaks? So again, we need different type of APIs in the running phase and also in the design phase, that we can integrate different systems, that we have the base load system, then we have the flexibility and demand side management in the other side also, that we can combine different systems. And without good APIs, so we cannot combine those systems and really optimize the performance during the whole lifetime of the building and of the area. And then when we go to the construction side and for this process, So many of you probably have read that construction is actually, the productivity is not that good in the construction side, and the productivity has not increased that much during the last decades. And that is what we are trying to now to tackle, especially with the data. So we need the data. This picture here where we have this green and blue and red shows actually different locations in our construction site and shows the times when people are at different locations so when they are doing the works. For example, plumbing work or HVAC systems or painting or something. So we can see that there is a lot of white. So how we are designing the whole process in a way that the logistics is there when it's needed, when the person who is doing the plumbing work, so that he or she has all the materials needed. So all that we need to know and in real time. So this is part of that how we are actually monitoring the construction side and how we get the information from different locations and how we are combining that to the logistics center, that we are estimating and having the just-in-time deliveries at the construction site. So and this is, of course, a lot of related to the cost and time which is used in the construction side. So and kind of like as a rough estimate, so 1 day in the construction site, so if it's delayed 1 day too much, so that cost us 10,000 euros. So it's really the time is money. So we need to understand how that is going. So again, so how we are making the data from different systems, what APIs we are using that we get the data, and here really in the real-time data. This is, of course, related to the quality issues as well, that we know that certain things are done in a proper day. We have the documentations there, and it's more and more about safety things also. We actually have in our construction sites, so each of the worker, they have this kind of like location tag that if there is some emergency situation, so we can track people there and evacuate them safety. So there is also this type of information what we need, and again how that is combined to the different models, what APIs we're using there. And then really importantly, it's also the environmental facts. So what materials we are using there, what are the origins of the materials, and also that we are not wasting the materials. If there is some leftover materials, so how we are using them maybe in the next construction site or some other purposes. So this is extremely important, and this is actually one of the most important things, because as I mentioned in the beginning, so construction industry is using so much materials that it's really crucial that all the materials, they need to be, of course, low carbon materials, but also that we know that we are not using them too much or not wasting them, but recycling and using it for other purposes. And then, of course, when the building is ready, so it's the whole lifetime of the building. So how we are using actually the design model for digital twin, for the facility management, for the services, for the energy. And energy is actually becoming more and more an issue because the energy prices are now really, really high. So how we make and guarantee that the prices are not that they are kind of like stable for the inhabitants and for the workers in the buildings. And then, of course, I mean, it's not only about energy. Living is about a nice everyday life. So what type of new services we get from the homes, making the life a bit easier. So smart home services, and also there that how we can actually, as easy as possible, connect different services, different applications, different appliances to the home, that these users can have his or her personalized services at the home, or personalized ventilation, lighting, and all that. And of course, when we are thinking about the data, so it's about cybersecurity. As you all know, so in Europe, there is so many people using daily internet, and different systems are so interlinked and interconnected. So we need to make sure that we have the privacy in connection in good ways, and also that we are prepared for the cybersecurity, because the amount and also the quality of the attacks is increasing. So this is a big business actually, and increasing all the time. So there is still many things what we need to do, but when I think kind of like what we are doing today, so we are building already quite good buildings. We are using 100% renewable heating, and also close to 100% of the materials at the construction site. So we are recycled or used in energy. So we are not wasting the materials. We are also reducing our energy consumption compared to the standard buildings, so 50%, and this leads to 60% reduction of the CO2 emissions. But still kind of like the materials are in the core. So how we are, especially concrete and steel, so how we are reducing those CO2 emissions. So there we are doing a lot cooperation with material fabrication factories. And of course, I mean, the energy optimization during the whole service life of the building is important. And this is where we are a bit special compared to other construction industry, because we are staying there 20 years with the building and making sure that the building is performing as we were designed. So we want to take the responsibility from there as well. And again, that we know and get all the information at the right time. So we need the APIs that we are using, that we get the real-time data and can react and prevent possible misusages. So as my last slide, so buildings and infrastructure, so they have really a long lifespan. They are there 100 or 200 years. And this makes us really kind of like we have a big responsibility, because the buildings which we are designing today, so they are used by people who have not even born yet. So we need to make them flexible in a way that the future users are happy also. Thank you.
Great talk, Miimu. Yes, you made sure that we all knew that there were APIs involved. That was great, because sometimes, I mean, it is not clear always that what APIs can even be used for. I mean, everybody gets the data side of things, but the APIs. But there is a question for you, or a couple of questions actually in the chat. So Daniel is asking, do you have an objectively calculated carbon emission of all processes, for example, trucks transporting goods to construction sites or something? There's a lot more that Daniel is asking, but maybe let's start about that.
Yeah, that's really good question, and we know best, of course, our own process, and there we can track all things directly. Then we are asking the material production companies kind of like that, what are the logistics and all that. And there we need to rely on that data, of course, because I mean we cannot track what are their factories and all that. But we are kind of like, this is part of our all contractors, that we need to know the origin of the materials, and this of course has the ethical meaning. So in that sense, so we are taking part of that, and also we are taking into account that how well we can recycle then the materials in the end of the life of the building.
Just as a curious question, because it used to be that in the logistics the APIs were not around. Yeah. So are they still there?
Yeah, you're right. I mean, this is still a bit tricky, and it's becoming better and better. But I mean, there is a lot of variation still. So that's definitely an area where we need to improve.
Yeah. So there's a question by Sharia about link between APIs and IoT to achieve the goals that you have.
Yeah,
so are you using IoT and APIs together?
Yeah, that's a good question. IoT, so that's really important, especially in the construction side. So it's actually IoT, what we need to use in order to kind of like get the information from different applications. So so we need to connect that, and it's also kind of like part of the end of the life also, and in the kind of like where people are living in the buildings or working in the buildings. So then it's quite a lot also that we are connecting the kind of like different things in the IoT and to the APIs that we get all the information. So that's crucial. Good question.
So then there's another question about ensuring cybersecurity in the construction sites and during the life cycle. Maybe okay, this is a sensitive subject, so you might not be able to explain all of it, but just shortly, is there like data and these IoT devices and APIs may be involved, or how do you see that?
So that's really important, and APIs play a really important role in the cybersecurity, because we need to, of course, communicate with different systems, and we need those APIs. And of course, the systems need to by itself be secure, but also that the APIs are designed in a way that the cybersecurity is fulfilled. Yes.
There was actually an interesting question yesterday when there was a securities track, and there were some Swedes and Finns in the comments, and they were asking, like the Swedes were asking, why is there such a focus on API security in Finland? Because it seemed that in Sweden, this is not some topic that is discussed so much. So have you seen any differences in kind of how surely these security things are taken in different countries?
There's differences in Europe, and I don't know especially about Sweden, because we are not working in Sweden. But it's certainly different, and for example, Germans do have different approach or are kind of like even stricter than what we are. But I think it's really. We need to take that seriously, because I mean the cyber attacks, the amount and also the quality is increasing. So I think that's really important topic.
Gunta is touching with her question an interesting topic that has been discussed a lot with different construction players. But what are the best practices, or are there any standards related to data and kind of construction and sustainability? So construction industry specifically is having some data standardization issues while there are practices, but what about the sustainability, and how do you see that between Finland and globally?
That's super good question. And the data from sustainability, so that's also kind of like growing, and also the standardization is, I mean, we have the basic standards, and we have the basic kind of like calculation methods, and how you are kind of like giving the CO2 emissions, and what kind of like what you are taking into account, and all that. We have the standards, but it's still kind of like the frame is there, but there is still kind of like differences between different countries and all that. So even though kind of like EU is now harmonizing it via taxonomy and all that, but there is still kind of like things what we need to do, and in order to be kind of like transparent as possible. So that's kind of like what we are always saying, that there are so many tools to calculate the CO2 emissions. So we need to kind of like be transparent, that we are showing that what are the methods we are using, what are the assumptions, what we are using, and all that everyone knows that you are comparing the same things.
Exactly. I think that is going to be a really good segue to the next talk. So thank you, Miimu, for joining us today. And it was a really, really interesting